Actually, today I'd like to talk about the appearance of early human in Jeongok-ri, Korea. So you now coming to Korea, so probably you want to know about the archaeology of Korea. So I want to introduce about the most famous archaeological site in Korea. So actually I'm a quaternary geologist, also I'm a geochronologist. So today I want to focus on the chronology, especially about the luminescence dating. So let me introduce first about the Acheulean industry. So what is Acheulean? Acheulean is the longest cultural tradition lasting for over 1.5 million years. And Acheulean industry is the first standardized tradition of tool making Homo erectus and early Homo sapiens. Also, Acheulean hand axes are that the stone was worked symmetrically and on both sides. So this Acheulean stage of early Paleolithic period began between 1.7 and 1.5 million years ago. But its end has never been accurately dated, just only broadly around 300 to 150,000 years estimate exist. And there are three Acheulean period, can divide the three parts, is early, middle, late, and then latest date for the African Acheulean is around 0.27 to 0.70 million years. So this is a distribution of the Acheulean cultural tradition. It's marked with the blue color. It represented from the Keynote 2021. And they divided for different area. This red color is the Asian area, and the green color is Sub-Saharan Africa, and the yellow part is North Africa and Near East, and purple color is the European area. So today I would like to show you these two case studies. First one is Sudan in Africa, and another one is Jeongok-ri in the Korean Peninsula. So I want to talk about the latest dispersion from the Africa and the final destination of the Acheulean into the East Eurasia. Let me talk first about the EDAR site. The EDAR is the Eastern Desert Atbara River site, and it's a very important Acheulean site in Sudan because it's a potential area of migrate route from the Africa to the out of Africa. So it's the area of Pota is there are many gold mining area, and they have excavation in the 4 or 5 sites, and they collected many Acheulean style hand axes. So I will introduce only one site. This EDAR 135 site. It belonged to the Middle Stone Age, and it divided the 3 stratigraphic units of fluvial sediments. And OSL dating, it shows very low dose rate. Very low dose rate allowed the dating of Asian sample over 200,000 years old. I will talk about OSL later. And this Acheulean artifact bearing horizon is younger than 231,000 years. And hominin occupation is the upper middle Pleistocene between MIS7 and MIS6 here. And this hominin migrated out of Africa toward Eurasia through the vegetated corridor during that time. So this, for those OSL dating, we calculate that this dose rate is quite low if we compare with the normal value. So we can estimate such an old age sample. So there are many papers about the EDAR site, and this paper is about the Saharan Green Corridor during the Middle Pleistocene. So this is like a green corridor, looks like a green corridor, and is responding to the Cotonic climate change. And this hominin dispersion of Acheulean tradition was channeled through the vegetated corridor of the Atbara River basin during the interglacial period since the Middle Pleistocene. So this paper represents about the latest out of Africa from along this Atbara area through the Nile River. So it's important things to the migration time. So let's move to the Korean Peninsula. This is the Jeongok-ri area. So Jeongok-ri Paleolithic site is located in the middle part of the Korean Peninsula. It's the most well-known and the most oldest archaeological site in the Korean Peninsula. This is a very typical Acheulean hand axis, and this is Jeongok-ri hand axis. It shows very similar in style to the Acheulean hand axis. So this type of hand axis considered the highest level of tool manufacturing at the time. This is a Mobius line. Mobius line is a technical difference between Africa, Europe, and Western Asia from those of Eastern Asia during the Old Stone Age. So it means the Acheulean culture is just only occurred in this area. It's not occurred at there is a more low technique. It's an old one technique was developed in that area, but there are many Acheulean style hand axes were discovered in this area. So it is really clear evidence against the Mobius theory. So today, this Mobius theory is no longer valid. But there are still big arguments about the manufacturing time of this Acheulean style hand axes in the Korean Peninsula. So one opinion is about the manufacturing time is around 400,000 to 300,000 years. But another opinion is just only around 40,000 to 30,000 years. So the first excavation of a Jeongok-ri site is already more than 40 years. It's first discovered from 1978. But there are still have a big argument about the manufacturing time. So Key et al. 2022, they shows many Acheulean excavation site, and this is a Korean site, but they marked as an ill-defined Acheulean present because of its the big argument about manufacturing time. Still, so let me show there are two excavation sites. The first one is E55S20 IB pit, and another is a 21 JGT section. In 21 JGT section, there are 4 trench sections and 3 borehole sites. And we collected these hand axes from the lowermost artifact horizon. So this is a 21 JGT section, and then this is a E55S20 IB pit, and there are 8 stratigraphy units. We can divide the 8 units, and there are 4 cultural layers like this. Now I want to focus on this lowermost artifact horizon. So this is a stratigraphic order from Jeongok-ri area. The lowermost part is a Paleozoic basement rock, and these parts are all quaternary sediment and basalt. So lowermost part is Paleo river gravel with the syndocenter matrix. We call this a Begiri formation, and the middle part is a quaternary Jeongok basalt, and the uppermost part mainly composed of unconsolidated fine-grained sediments, including the artifact horizon. So we can date it using the beryllium-10 for these fluvial sediments. We can measure the burial age, and we measure the argon-argon dating for this Jeongok basalt. And we measure the luminescence dating for this for most unconsolidated sediment using luminescence dating. So we use 3 different kind of luminescence dating: is quartz, fine grain quartz OSL, and fine grain quartz TT OSL, and single grain K feldspar post-IL IRSL dating. So that we compared with these age results. But today, just I want to show you these 2 results because IRSL is not finished yet. And we collected quartzite fragment, hand axis fragment directly from the horizon, artifact horizon. So we measured beryllium-10 for the burial age. So based on these age results, we have compared the chronostratigraphical consistency. So let me introduce about the luminescence. So what is a luminescence? We mainly use quartz and most feldspar for luminescence dating. And these minerals are exposed to the light during the transportation from the basement rock to the during the transportation. It completely exposed to the light, and it removed all luminescence signal during the transportation. And after burial, it exposed to the natural radiation such as potassium, uranium, thorium, rubidium, and these electrons accumulate during the burial period. And if this mineral exposed to the light or heat, it emitted the energy as a form of light, which is called luminescence. So this is about bleaching event. The bleaching event is very important because during the transportation of sediments, it should remove all luminescence signal before burial. And then after burial, it accumulates the luminescence signal, and when we collect the sample, we can measure the natural signal. But if not, it's bleached well, so we call this partial bleaching, and it caused the overestimation of age. So this is about age calculation. So the luminescence signal acquired during the burial period, we call this equivalent dose. We mark as a DE value. And this is radioactivity of sediments. We call this a dose rate. And we measure this from the ICP mass or gamma spectrometer. So OSL age is calculated from dividing the dose rate, dividing equivalent dose by dose rate. So we can collect the sample directly from this trench section. Also, we collect the sample from the vessel by drilling, and we also collect the sample from the land side. So this is about the luminescence dose response curve. So this graph shows that this dose response increasing to a maximum value, and it does not increasing further. This is a natural signal, and if we plot it, we cannot plot it on this dose response curve. So this single type of trap in this mineral was already filled up, and we call this saturated. So we call this a saturation. But this graph is still growing up, and this natural signal is not saturated yet. So we can describe this like a hotel room. There are limited empty room, and if it's already occupied for all room, and with its same with the oversaturated range, so we cannot book anymore. But it's still empty room. We can book more, so it's still under saturation range like that. So for the age dating, I use a TTOSL. So just I want to show you about the TTOSL. TTOSL is a thermally transferred OSL. It has been investigated for extending the age range, and recently there are many research is about the TTOSL. This is one of a case study about TTOSL for the Brunès-Matsuama boundary from Wang et al. 2006. So this is a BM boundary, is a magnetic reversal boundary, and it measured using the argon dating is about 776,000 years. When they applied the TTOSL, and they obtained the 790,000 years. So the age are quite correlated well. So it means the TTOSL can be applied to such an old aged sample. So this is our transit section, is E55S20 IB pit. There are 9 OSL samples were collected from the upper 5 meter, and 2 Badalto samples also collected in the bottom part. And the oldest and highest concentration of artifact is found from the 4 meter below the surface. So this is a OSL signal. If this mineral exposed to the light, they emit the light like this, and it decayed quickly. After 300 seconds, if we hit the sample again, it makes another luminescent signal, much smaller signal, but we can measure much higher those ranges, and we call this TTOSL. So there are 3 type of TTOSL, TTOSL and BTOSL. BTOSL is basically transport OSL, and the REOSL is just subtract the BTOSL from TTOSL, and we obtain this REOSL. So finally, we calculate using this REOSL for age dating. And one of the problems of TTOSL is it is really difficult to bleach the well. When we use a solar simulator for bleaching test, is for the 7 days, and it still remained 38 degrees, 38 grade. So it's really difficult to bleach the well. So TTOSL is sediment transportation system is very important. Our sample, we think, is from the Aeolian sediments. It is suitable for this TTOSL. But it's not suitable for the fluvial or alluvial sediments. There are 2 dose response curves. It's just a conventional OSL, and this is a TTOSL. So this dose response curve of a conventional OSL shows continued growth beyond 800 gray, and TTOSL shows much higher growth up to the 2500 gray. And each data point quite agree well, so it can make a construction of SGC. SGC is a standardized growth curve. So when we compare the equivalent dose value between OSL and TTOSL, this sample is the middle part of a sample. They shows around 650 gray. So it shows quite similar value. But for the lowermost part sample, it's the oldest sample, shows much difference. It's not increasing more, but TTOSL equivalent dose value is much higher than this one. So if we compare with the conventional OSL and TTOSL, they shows good agreement until 600 gray, but over 600 gray, TTOSL increasing more, but conventional OSL doesn't increasing anymore. So we use a dose recovery test between OSL and TTOSL. It's quite necessary step to check the ability to recover a known laboratory dose. So before the E measurement, bleaching using the solar simulator for 7 days, and given those are ranging from 0 to 1.1 to 1,000 gray. This is a conventional OSL result. Over 600 gray, they shows a 10% underestimation. But for the TTOSL, until 1,000 gray, they shows a good agreement between given dose and the recovered dose value. So this is age result between OSL and TTOSL. Stratigraphically consistent up to 150,000 for both OSL and TTOSL. for the upper 5 sample, but beyond 150,000 years, the OSL shows a serious discrepancy with the stratigraphic order, but TT-OSL age up to the 200,000 years, and it shows a stratigraphically consistent age result. And the main artifact horizon is dated as approximately 200,000 years using the TT-OSL. So these TT-OSL results mainly belong to the MIS-7 to MIS-5, and the low two basalt samples, they shows around 520,000 years. This is our another trench section, is 21 JGT01, and we also use OSL and TT-OSL. And TT-OSL, the dose response curve shows much higher growing, and they shows a nice dose recovery result. And from the upper part sample to the lower part sample, equivalent dose value between OSL and TT-OSL, they shows quite agree well. But one problem is the lowermost part samples, the TT-OSL, the E value is much higher than conventional OSL value here. So this is an age result. So it's consistent up to the 180,000 years between OSL and TT-OSL, but TT-OSL age are up to the 240,000 years, and it shows a serious discrepancy between OSL and the TT-OSL. Yeah, I already mentioned about TT-OSL is difficult to bleach well. So if TT-OSL age, it may be overestimated if the signal will not fully bleach that deposition. Nevertheless, the TT-OSL age cannot be younger than the oldest conventional OSL age of 180,000 years. And if we combine with the previous excavation section is E5S20 IP pit, and we combine the age, and it shows a really good agreement to each other. And the main artifact horizon around here, and it's dated as approximately 240 to 200,000 years. So in this section, we collected this fragment of hand exit. We collected directly from the lowermost artifact horizon, and we measured the beryllium-10 dating, beryllium-10 burial dating, and we measured the beryllium-10 and aluminum-26. So isochrone plot of the beryllium-10 against the aluminum-26, it demonstrates that the burial age of hand exit is approximately 250,000 years, like this. We collected 3 borehole samples. It is a borehole photo. We collected sample like this, and we measured the beryllium-10 burial age from this lowermost fluvial sediment here, and this age range is around 600 to 650 to 620,000 years. And we collected basalt sample from this part, and we measured the argon-argon dating, and the age range is 547 to 515,000 years. As I already mentioned before, the uppermost consolidated sediment age range is around 250 to 85,000 years. So this is a comprehensive interpretation of age result. The lowermost fluvial sediment, we call this Begri Formation, is around 620,000 years. And then the middle part, basalt, is around 520,000 years. And on our excavation site, E55S20 IP pit, using OSL, TT-OSL, and it shows around 100 to 200,000 years. And another pit is a 21 JGT pit using the OSL and TT-OSL, shows age range is 85 to 240,000 years. And beryllium-10 dating from the hand access fragment is around 250,000 years. So these overlapping of age, It means all the human occupation in that area is around 250 to 200,000 years. So this is one of a Nature paper in 2021. It's about the multiple human dispersal into Southwest Asia over the past 400,000 years. It is collected these hand axes from the Arabian Peninsula, and age dating shows it's correlate quite well with the interglacial period like MIS 11, MIS 9, 7, 5. It means the human dispersal is closely related with the interglacial period. So this is average temperature during the 250 to 150,000 years in the Korean Peninsula. I use IBS climate model, and during the MI7, the average temperature is 11.3. It's the interglacial period, and is our human occupation period here. And the MI6 is average temperature is around 9.5. This is recorded average temperature during the last 100 years, and average temperature is around 13.2. But it's increasing abruptly. Now is 14 to 14.2. So just 100 years ago, the temperature is only 11.8. So this temperature is quite comparable with the MI7 stage. So this is a modern summer monsoon area. This is a shaded area, is a summer monsoonal boundary, and this is the East Asian monsoon, and Indian summer monsoon, and Asian winter monsoon. And this is the all Acheulean excavation site from Arabian Peninsula, India, and China, including Korea. I plotted just the location here, and when I overlap the modern summer monsoonal boundary graph, and this excavation site is plotted just within the summer monsoonal boundary like this. Probably the Acheulean dispersal is along this way to the easternmost part. So this Acheulean present in the Korean Peninsula during MI7 is constrained the chronology of Acheulean approach to the easternmost part of Asia. And this expansion could be related to the interglacial summer monsoon. This is just age plot from each section. If they measure the absolute date, and I plot here, and this y-axis is the age, and looks like this. And this is probably density plot in Arabian Peninsula, India, and China, including the Korea. So I'm not really sure about the difference, but it's just a little bit difference because the Arabian Peninsula shows more all the data, and China area it shows around the middle part. The dominant middle part age range is around 800,000 years, and India shows relatively younger dominant age range here. But I have to consider more about that, and I need to collect more age data. So this is my conclusion. So beryllium 10 age of the lowest fluvial sediment in Jeongok-ri area is around 650 to 620, and basalt is approximately 520,000 years. And the Jeongok-ri sediment shows age range from 237 to 85,000 years, and beryllium 10 age from the hand axis is around 256,000. So the earliest artifact is founded constrained by T2S and beryllium-10, and this manufacturing period is around 250 to 200,000 years. So we need a further age comparison between OSL and the K-field spark IR cell dating. And this Acheulean culture at the easternmost part of the Asia is likely connected to the interglacial summer monsoon. Okay, thank you very much.